Okay, so the first thing we did when coming up with the graph of tangent was go through the entire unit circle for tangents and look at all those values. This is where we first noticed the pattern of, angles over 6. It's going to be root 3 over 3. Angles over 3, it's going to be root 3. And we used some of those values to plot the points for tangents. We also noticed that tangent repeats every pi, so it's every half of the circle it repeats itself instead of every 2 pi. So we mentioned that the period for the tangent graph is pi and not 2 pi like it would be for sine or cosine, or secant or cosecant. Then we also talked about characteristics of the parent function, which is that it takes up 5 tick marks on the graph. You've got a middle point, you've got 2 stretch points, you have 2 asymptotes. Tangent goes through the origin, has sort of a positive slope type angle to it, kind of looks like the letter T, etc., etc. So that is tangents. Let's talk about cotangent for a sec. So cotangent is the reciprocal of tangents, which means that on the unit circle, cotangent equals x divided by y. So here's sort of the key thing that we want to think about. When we do, let's say, tangent of pi over 6, what does that equal? That equals root 3 over 3. And what we're doing is we're doing 1/2 divided by root 3 over 2. And we do all that division. And it equals root 3 over 3. When we do cotangents of pi over 3, pi over 3 is, up at the top of the circle, we would be doing x, which is what? What would the x coordinate be at pi over 3? 1/2 divided by root 3 over 2. So we know that this is going to equal root 3 over 3. So it's the same numbers being divided. And similarly, when we do tangent of pi over 3, what does that equal? Root 3. So cotangent of pi over 6 would equal root 3. Because we're just switching whether we're dividing y divided by x or x divided by y. But it's the same numbers. When we do tangent of pi over 4, what does that equal? That equals 1. What would cotangent of pi over 4 equal? It would also equal 1. Because x and y are the same. So if we flip them, it doesn't matter. We get the same number. For a tangent of 0, we're doing, y divided by x. It's 0 over 1, which is 0. Cotangent 0 would be 1 over 0, which would be undefined. Similarly, tangent of pi over 2 is 1 over 0, so that's undefined. Cotangent pi over 2, what would that equal? Flip it, so that's 0 over 1. What's 0 divided by 1? 0. So it's all the same numbers as tangent, but flipped. And so we can use that table of values. We can also use the graph of tangent itself to help us with this. So we know that, well, the period is going to be pi. It's same as tangent. So we're going to label our x-axis the same as we did with tangent. And we know that cotangent of 0 is undefined. So what does that mean that we have at 0? A vertical asymptote, yes. A vertical asymptote there. I'm just going to mark off 1, -1 right there. Cotangent of pi over 4. Cotangent of pi over 4. 1. Yeah, I can also see like, okay, well, tangent of pi over 4 is 1. Reciprocal of 1 is 1. Cotangent of pi over 2. 0. Okay, now we didn't keep going with our cotangent list here, so let's look at the graph of tangent up here. At 3 pi over 4, tangent equals -1. What's the reciprocal of -1? -1. And then what would cotangent of pi be? Undefined. So tangent equals 0. That means what we were doing was 0 divided by 1. So reciprocal of that would be 1 divided by 0. It's going to be undefined. So we get this cotangent shape right here. And what does that remind you of? Yeah, tangent specifically. What kind of tangent? Negative tangent. Yeah, it looks exactly like negative tangent. What do you guys think we're going to see on the left side of the graph? Same thing. So we got, it's 5 tick marks, just like tangent. So we have our asymptotes. Then we have halfway between the center. And then we've got our stretch points there. So big differences. Tangent, the graph passes through the origin. Cotangent, we have an asymptote at the origin. Tangent is going uphill, positive slope type graph. Cotangent going downhill, negative slope type graph. Other than that, they're the same. 5 tick marks, center point, stretch points, 2 asymptotes, same period. Shifts are all going to work the same way. Domain is going to be slightly different just because of the location of the asymptotes. What would we say that x cannot equal? 0, but then it would be plus pi k. Yeah, so that number before k is always going to be the same as the period. And range, all real numbers. So if tangent was making sense to you, cotangent is just a slight variation. Questions on the parent function? Let's go to the next page. Okay. So now we're going to do all these transformations here. So we'll do the first one all together, then I'll let you guys do the other ones. So we're going up 1 for this first one here. So again, it's helpful to graph a dotted line to keep track of where the middle is. So that's where our center point's going to be, kind of level with that. And then we have our stretch points. Is there any stretch to this? No. What's the normal amount to stretch? Just one. So let's just mark off up one from there and down one from there, just to remind ourselves. Is there a period change to this one? No. So what would the far tick mark be? Okay, and again, it's like our origin's been shifted up one there. Cotangent parent function, what passes through the origin? A vertical asymptote. So I need an asymptote there. Where would my other asymptotes be? Pi. Negative pi. Yeah. Where would my center points be? Pi over 2. And then cotangent right, as I go to the left, it's up, and to the right is down. So it's like upside down tangent. We would see the same thing over here. And again, to graph these and make them pretty, start at the middle and curve upward through that point, and then go back to the middle, and then go downward. Remember, guys, appearance is happening. Your graph. Domain and range would be the same as the parent function for this. No, that's a little O for origin. Yep. Okay, so I'm gonna have you guys do the rest of these. A couple quick notes before we do that. To calculate the period, any guesses what it's going to be for cotangent? Is it pi over b? Yes, it is. Same as tangent, it's pi over b. Sine and cosine, secant and cosecant, it's 2 pi over b. Tangent and cotangent, pi over b. And then for this example right here, let's go ahead and change this to let's say pi over 4, x minus pi over 4. So when we see 2 cotangent x, what is that doing? Okay, amplitude is technically not correct because this is not a wave, and only waves have amplitude, so that's an important distinction. But it does do the same thing that amplitude does, which is stretch, vertical stretch. Okay, but there's no other shifts. So we have our asymptote on the y-axis here, and over here, and over here. We have the middle center point there in between them. The only difference is now we're going to go up to 2 and down to -2. Again, you can label your y-axis however you want to show that stretch. This graph can be identical to the parent function if you label it differently. Totally fine, just make sure that you do label. And sometimes, I'll miss the points right there, but, they're going through them. Question on that one? Okay. Next one, what is the new period of cotangent 2x? Pi over 2, so this one's going to be pi over 2, pi over 4, pi over 8, 3 pi over 8. I feel like we saw this x-axis arrangement a few times last class. No vertical stretch here. Remember, and this is a common confusion point, sometimes you see this 2 here, and you change the period, and then you're like, oh, it's a vertical stretch of 2. No, it's not. That 2 on the inside only changes the period. It's not also a vertical stretch. once we change the x-axis like this, we can just graph the parent function like we normally would. Again, this is the whole point of changing the x-axis, is so that we can graph the parent function over and over again, so that it always takes up 5 tick marks, like this. Again, same as sine, cosine, tangent, secant, cosecant. Does this graph look like it's been compressed from the parent function? It does not. But by the x-axis, we can tell that it has been compressed. It just doesn't look like it. Domain would change for this. So we would say x cannot equal 0 plus pi over 2k. So now that the period's changing, the domain is going to change as well. Range, of course, is still all real numbers for all of these. Now, this one here that's going right, pi over 4. Again, that's the only thing that's happening, so I'll just get everything else ready. So when we get to the right pi over 4, it's like our origin is now here at pi over 4. For cotangent, what goes through the origin? A vertical asymptote. So it can feel weird to draw an asymptote first thing, but also remember, like, that's what we did with logarithms and exponents, right? That was always the first thing that went down. So asymptote there, and again, if we're thinking this takes up 5 tick marks, it's 5 tick marks counting this one, where would my other asymptote be? Negative 3 pi over 4. So as I count those up, it's 1, 2, 3, 4, 5 tick marks. So where would the center be? Pi over 4? Negative pi over 4. And where else? 3 pi over 4. Yeah. So it can be helpful just to put down the center points. And then from here, like cotangent shape, stretch points go up, then down. Up, then down. This one over here, we would see just the down part of the stretch. Oh boy, that's bad. So yeah, again, if you focus on those 5 tick marks, when we shift to the right or to the left, they're all going to move together. Like here's no shift, and then we shift it to the right. Boom, there they go, all together, just like that. Just take a look up here real quick. You don't need to write this down, but if we do what the problem originally said, and we shift it to the right pi, we would not see any change of this graph here. We would have an asymptote at pi, and like our kind of original parent graph would be over here, off the graph. But we would have asymptotes here and here. It would not look like any shift has happened. So in case you were wondering, if we're shifting a whole period or multiple periods, it's going to look like nothing's changed, because it's basically just replacing what was there with the same thing. So it would look like that. Okay. Cool. Let's look at number 4 on the next page. Okay, so this one kind of looks like it has a lot going on, but it's actually not that much. Is there a vertical stretch? No. Is there a vertical shift? No. So nothing out front, nothing over here. Is there a period change?
Yes.
Yeah. So if I do pi divided by b, what's pi divided by 1/2?
2 pi.
2 pi. Okay, and then this one is going which way? To the left. How far? Pi over 2. This one is in standard form, right? The 1/2 is factored out. What would we draw at negative pi over 2?
0.
An origin, what goes through the origin? An asymptote, yes. So we're always starting off with our vertical asymptote. In cotangent. Where would the other asymptote be? 3 pi over 2. You count over there. A total of 5 tick marks, or like 4 away from this one, because you got to count this one. 1, 2, 3, 4, 5. There it goes. Which means my center point would be where? Pi over 2. And then I can get those stretch points. I would have another center point. Where would that be? Negative 3 pi over 2. And over here I would see just like one stretch point. Questions on that graph? Domain. What can x not equal? 3 pi over 2 or negative pi over 2, yeah. And then plus 2 pi k. You know, it's going to be the same as that. Range, all real numbers. Yep. Yep. Okay. Now it's your turn. You guys do number 12. Okay, first thing would be what?
Mark the x-axis.
Mark the x-axis. Okay, we can do that first. What would go here? Last tick mark. Pi over 2. What else would I want to do?
Label the y-axis.
Label the y-axis, and then I also heard take away the 2. Yeah. So, okay, for labeling the y-axis, we're going up 1, and then we have a stretch of 3. So my middle is going to be at 1, and again, I can choose like what I label as 1 and whatever, but there's up 1, and then from there, my stretch points would be 3 above that. 1, 2, 3, and 3 below that. 1, 2, 3. I need to take the 2 out. When I take the 2 out, I get x minus pi over 4. So that means I'm going to the right, pi over 4. What should I draw at pi over 4? An asymptote. Where should I draw the other asymptote? Negative pi over 4. We're just going to count those tick marks. 1, 2, 3, 4, 5. It's the 5th one. Okay, and so then my center goes right there on the dotted line. And then my stretch points just need to go up 3 and down 3 from there. And then over here I see the middle. Over here I've got middle and down. There's our graph. Yes. Domain? Oh boy. X such that X cannot equal?
5/4 plus 5/2.
Nice.
So that's what it means.
Yeah, the vertical line means such that. X such that. Oh, that's a bar.